what we are going to be doing today is very important for all of you. And the reason it is important is understanding the blockchain ecosystem is one thing, but I think most of you here are interested in building things in blockchain. So where do you start? Now that's a conversation which is very, very important for us to give you confidence. And either you are a Web2 developer already, you have spent some time in building stuff in Web2, or and you want to start looking at Web3 as your career choice, or you are a fresh Web3 developer. Does not matter. Our objective today's session would be to give you absolute clarity in terms of what is building in Web3, all about, right? So with that objective in mind, let's start. Before I go deeper into the conversation, I would also like to point out that while you learn these technologies with us, while you try to come up with your ideation, while you come up with, a promise to build something in Web3, we have got, a series of, reward system, which really will keep you motivated to go to the further stages in building process. Now, this is something which is very, very important. And I think, these are the extra incentives that you get apart from being or gaining expertise in the stack, right? We will encourage you, we will request you to go and watch these recorded sessions in the IBC media portal, which has been shared in the in the chat here. What we covered right now, before we get into the technical stuff, we must first appreciate what is blockchain and why is this blockchain so important. When we say what is blockchain, you all now pretty much understand that it all started with Bitcoin, which was meant to be a peer-to-peer, money movement system, right? Without having any third party or intermediary. Now, this statement is a very loaded statement. To make this happen, there has been, a bunch of technologies, they have been leveraged in making this happen, such as cryptography. You talk about, consensus mechanism, Sybil resistance mechanism, right? And of course, there are several things which really have gone into making this system work. Now, I have also talked about in the past that none of these technologies were invented when Bitcoin was invented. All of these technologies were existing beforehand. What really was done by this called Satoshi, that he brought all of these technologies together in such a way that they all started solving big problem that the whole world was facing. And you must appreciate the fundamentals of blocks being formed, how transactions, get included in a block. What are the different validations which are required for a transaction to get included in a block? How do different nodes come together? And then they look at the blocks, look at the transactions, look at the block's metadata. And finally, they agree upon that, look, this block is the next block, this block qualifies to be the next block. And all these fundamentals really have worked very, very efficiently for the last 15 years. That really gives a testimony to the success of the whole technology stack that was, conceived in 2008. But then, as you also know, that Bitcoin for sure, became extraordinary in terms of its ability to solve some of the real world problems, but it still was limiting in its application. And that is where the flurry of innovations starting from Ethereum. And the first thing that Ethereum tried to solve was that, can I come up with a platform which can solve much more than just being a payment solution platform? And that is where the evolution of EVM happened, which is Ethereum Virtual Machine, which has the capability to solve any real world business problem. And from there only, you started having, DeFi, coming into picture. All the problems in the finance world, they were started, being experimented in this blockchain space without third parties, such as exchanges, lending, borrowing, of course. Then you have got different kinds of derivative products, right? You could look at the usage of blockchain in various other industries, such as gaming industry and supply chain, logistics, be it music, be it crowdsourcing. So the applications became endless. Now, once you understand all of these things, then the natural question that comes to your mind as to how do these things happen, how do these virtual machines work, what is the role of different validators, right? What is the role of various users, what is the role of the applications, right? How do they create liquidity, what are the different types of liquidity, right? And what other things you really need to understand before you really get into this space. Now, with this context, now let us move to the next subject. Now, I would my objective of today's session is to give you an introductory view of the things, and then I would request my co-speaker Avinash to get much deeper into many of these things, right? So, with this context of the utility of blockchain in the real world, let's get into defining dApps. And you may have heard this term several times before as well. So what exactly is decentralized application? So like we said, decentralized applications are applications which are not having any centralized control, which are not supposed to have any centralized control into any of the component of the application. What does it really mean? It means that, for example, when you compare a centralized application to a decentralized application, what really happens? And there are enormous number of examples of centralized applications. For example, the application that you use to interact with your bank, for example, the application that you interact with for the social media requirements, the applications which are there for you to do retail shopping on the internet, right? All these are centralized applications where the control lies in one central entity. Now, there is no issue in this control, but then there is huge amount of issue because we have seen the excessive, the power corrupts. Now, when you have got accumulated excessive power within you, then definitely, there are chances that, this gets misutilized, this gets misappropriated. And that really has happened, umpteen number of times in the history. Now, that's where I think decentralized applications are the applications which are supposed to, and I'm using the term supposed to very consciously, because in the current world of decentralized application, there are still some extent of centralization when it comes to front end, for example, right? If you go and make your application completely decentralized, but you host your front end on some centralized server, or for example, cloud server, then you are not a centralized application. So we'll get more deeper into that, but essentially, this is what really a decentralized application means. And I mentioned about applications which are there in the central world, where you have got a data center, your servers host the database, your servers also host the backend code, and all the control of these databases, all the control of these applications, whether these are backend applications or whether they are the front end part of the application, everything is controlled by one entity. And you are, at the helm of being manipulated at any point in time if your interest clashes with the interest of the central entity. Now, that liberty is coming to you by using dApps. Now, these dApps are basically a mechanism in which you function as efficiently, and in fact, in some way better than the centralized systems, but without being controlled by one central entity. Now, that's the thing that the world is loving, and that's where you will see today that there is a replica of any application in the central world that's being made in decentralized world. There are several other benefits which we'll talk about, but in essence, this is what it is. Okay. Now, if you really look at the core features of dApps, what are those? There are several others, but one thing that we love about decentralized application world is open source. And that's really, in fact, one of the things that I have always appreciated in this world is that people do not constrain themselves from sharing their source code with the world. And it has got one major advantage, that there is a term called composability. Now, composability in blockchain world is basically where you go and use something which is already built by somebody, and you can go and build on top of that, such as if you know about the Lego blocks, where you go and fit in two components and make something like that, which is really a working model. That is what is something, and one of the reasons why this environment has been thriving for so many years is the open source culture everybody believes in, and I think that is something which is very, very important. We talked about decentralized nature of the applications. Now, this decentralized really could mean several things. Now, first of all, at the infrastructure layer, with the blocks, or the blockchain upon which the applications are built, they could be Ethereum, they could be Solana, they could be Avalanche, they could be layer 2 applications such as Arbitrum, Optimism, or the ZK-based blockchains. They could be anything. But the way these blockchains function, they are truly decentralized. There is no single person who comes and says, okay, this is going to be the next block. No, this doesn't happen like that. The decision is arrived at by all of these people working together, and the majority wins in a consensus way. Now, that is one. Second thing is that I also see decentralization in a way that when you host your application on top of these blockchains, then also you have to think of the point that you should not be, checked or controlled by any entity, whether your backend is completely decentralized, whether are you under the influence of some entity or group of entities. Now, there are so many deeper thoughts which we will talk about when we kind of move further in this in this course. But for today, what I'm keeping myself to to the extent that you are not, nobody has the power and authority to come and check you that, look, you cannot do this, right? But the system or the community can decide, as a whole. That is very important. Third thing, and typically we see that one of the most important things, and I know Avinash will cover a lot more detail into this point, that in Web2 based system and model, what really happens that the incentive or the monetization of your work, that does not come to you, to a large extent. So, for example, you are the creator of something, you should get 100 rupees, for doing that work, but you get 10 rupees for doing that work. And that is true in most of these Web2 systems. Now, if you look at the Web3 based system, where you go and talk about incentivization, so incentivization of the effort is done, whether it is block creation, whether it is participating in a decision, whether it is anything. But then this system is driven by incentives. And this system also has got a checkpoint with when you do not behave properly, you get penalized. Now, that's how the system works. And finally, it is a protocol based. Now, what exactly is a protocol? Protocol means a set of rules, Now, you can very well imagine that if you are working under the influence of a centralized entity, there is one person who takes all these decisions. No problem in that. And things are pretty straightforward. But the moment you come to a system when there is no one person or entity who can decide for everybody else, then the chaos comes there. Chaos happens, right? So in that situation, what really happens, the system, agrees upon a set of rules, that these are the rules which everybody will follow. And then the system keeps on working. Now, if there is a change in the rule that has to happen, then all these people come together and then they change the rule also. They can do that as well, right? But at the same time, you have to say that whatever happens here happens as a part of, a group which is following a rule. Very, very important. So some of these things you should definitely keep in mind before you get deeper into the building part, right? Let me take a very, very, generic user flow here. You start with, application, a front end, where a front end is a web browser. Now, this could be anything, Chrome, Opera, Safari or anything, right? And the front end will look exactly like what you used to see in Web2. The only difference being that you are not supposed to have a user ID and password based authentication here. You are supposed to be interacting with the blockchain with your wallet, right? We will again talk more on that, but then for the time you understand that your entry into the application happens through a wallet, and that application will be hosted on some blockchain. That could be Ethereum, that could be Polkadot, that could be Solana, that could be anything, right? And every blockchain has got its own set of fundamentals, and those fundamentals could mean that how exactly what cryptographic primitives have you used for generating your private key and peer and public key, for example, right? And there are so many other aspects that really need to be taken care of, right? So you get into the application, and these applications basically are now they run into a virtual machine instead of a server. They run into a virtual machine. Okay. Now to access that virtual machine, to access that application on a particular blockchain, you have to have something called JavaScript library. If you are working on JavaScript library framework, whether it is JS, whether it is Angular, whether it is anything. So there are different frameworks or libraries such as Web3.js, then you have got ethers.js. There are several of them. They give you an ability to connect your front end to the back end. There are different commands, right? I mean, you have to go and read into them. And finally, there are, RPC endpoints, remote procedure, calls. And through those calls, what you do basically, you go and hit a node, which is a part of that blockchain, and that node will act on your behalf for in interacting with the blockchain. Okay. Now, when we do that, then there are several other complications from which we'll not talk today. Maybe Avinash will talk some of them today, but then we will be talking about all of these things in much more detail in next 2 months time frame. But for the time being, you approach a node that you could run that node yourself, or you can go and take any services of any node providers. For example, it could be Alchemy, it could be Tatum, it could be anything for that matter. And you go and tell the node, those guys will run node for you, and your request will go to that node, and that node will interact with the blockchain on your behalf, right? And when this request goes to the blockchain, then it goes and hits a smart contract at a very high level right now. And a smart contract has got all the logic which is inbuilt into that, and based upon that, you get responses, and the communication comes back to you, to the user. That's what exactly we're talking about, when we look at a journey, of a user, or how do these dApps work. Okay. Now, before I give, control to Avinash, there are few things that you need to understand. What is a smart contract? A smart contract is nothing but a self-executing code where you have already decided that how will this contract behave when some request or when some call comes to the smart contract. Very, very plain and crude language. You say that, okay, when I say this is a function which says pay function, for example, or this is a function which is lend function, for example, this is just like any object-oriented programming where if you have worked in the class and object concept, something very similar, where you have got these functions defined in the smart contract. And when you go and hit those smart contracts, then what does that function need, what are the input parameters, and when you supply those input parameters, the function will behave, and it will emit logs, it will give you events, it will do a lot of things, right? So don't worry about all of that. But in the very, very basic language, a contract in the real world happens between two people, where two people agree on some terms and conditions, sign them, go and notarize it. That's what they do in the real life. The same thing happens in a blockchain world, which is called a smart contract, which is nothing but it's a program. Okay. Now, the important thing I want to cover here before before I go to the next stage is basically the storage thing. That is very, very important thing. You have to understand that in the real world, you have got databases, you have got different storage services such as S3, from the AWS, and similar services from other, cloud service providers. You may have your own on-prem servers to keep stuff. In blockchain world, you could have different types of storages, right? One is on-chain storage, another is off-chain storage. Now, why is this important? Because you have to understand that the EVM that we talk about, if you start storing everything on the on-chain database, then it becomes too much, and it becomes very, very expensive affair. This is not sustainable. That is where mechanisms have been brought right now, which are decentralized, peer-to-peer networks, such as IPFS-based solutions, where you can go and store your required objects in these storages, which are also, content addressable. What I mean by content addressable, when you change the content, for example, the address changes. Now, that's the beauty of IPFS-based solutions. And that really has been a very, very, I would say, good breakthrough in my opinion, and a lot of projects, a lot of protocols have come based on all these concepts, right? But many times what I see people going and storing their objects into the centralized servers, I think that is not true in the true spirit of decentralization, in my opinion.
Okay, thank you, that was very insightful. As always, Praveen sir, good to hear you. If you look at what has been discussed so far, we talk about blockchain, we talk about smart contracts, we talk about dApps, but just considering the thing that we have audience coming from, I'm assuming there are people who are from CSC or computer science backgrounds, and there are some people who are from non-tech background, and people who are from tech background and might not be interested in coding, right? Just to tell you, this technology, this orientation, these sessions is to educate, saying, one, you can be from any background. Two, you don't have to have any programming understanding. And three, you can ask any dumb question. It's okay, because we always do that, right? No question is a good question. No question is a bad question. If you have a question, it has to be asked. So to get started, and just to give a perspective of what I have here, I want to split this session into 2 parts, or maybe 3 parts. One, we talk about the architecture, the migration or the shift from Web 2.0 to 3.0. Talk about the tech stack. Second part is I would want to spend time a little bit in terms of how this blockchain looks like. What does it mean by a transaction? What does it mean by a smart contract? I would want to actually also show you how a smart contract looks like on the network. And in this context, we'll look at one particular use case, and we would want to go in detail at one particular use case, talk about what this smart contract means. And then the third step would be talk about some use cases and some adoption, and then we'll have a small Q&A. So that's the schedule for now. And I think if I get started and talk about the Web 2.0 to 3.0, currently there is the trend that we talk about, where we say, if you look at here, we talk about focus, technology, ownership. Here it talks about 3D graphics, no and yes, but I think it's in terms of the kind of applications that we are seeing in Web3 for the graphics, whether it is metaverse, whether it is all kinds of application which is very graphic intensive and content rich applications, right? And then you have your target reach, you have types of applications. So take a look at the Web2 applications, where we have your Facebook, Instagram, all kinds of current client server type based applications. And then you move to Web3, where we are saying that the ownership of the data is owned by the person. It doesn't mean that today, if you log into Facebook, Facebook has your data. But today, if you launch a decentralized application, like what we have been hearing in terms of the concepts, the data storage is not the data sharing is not happening to the company who's running it. For example, here the data is owned by the person. So if the way I interact with the network, the way I post transactions, it's specific to me. My data stays with me. It doesn't mean that my data is shared to the service that I'm using, right? So if it's a curve that you look at and the trend that's following, right? Here In Web 1.0, we had very, very static websites, basic HTML, browsers like Netscape and old Mozilla and other read-only websites. That's early 90s, mid 90s. And then we had a Web 2 where we talk about dynamic information, we talk about learning, we talk about machine learning picking up. Then we also have a lot of data which is being shared and learned upon. So as an example for Web 2, where we say that I keep giving the example where you get a recommended engine, right? So you go on Amazon and then you search for something, you get recommended products, right? So people learn from your history, your transaction history. That means that the data is being shared. Even in terms of a recommendation engine where you keep using Instagram and TikTok and all, where the type of videos that you watch, the same type of videos you keep getting. For example, if you keep watching healthy cooking videos or health tips and all, you still keep getting those videos. So your data, your web presence is being shared and learned upon, and basically you don't get even incentivized for it, right? For data sharing. Now we're trying to do this shift from the 2.0 to 3.0, where we're saying everything is decentralized, my data stays with me, and I'm only posting a transaction through a wallet ID or a unique ID or an encrypted ID, where we're still executing the transactions, we're still executing the processes, but it is all decentralized. There's no one centralized body, like Praveen sir was mentioning about different types of blockchains. And currently, we're not talking about how the network is managing its nodes or adding transactions to the blocks and how the blocks are being added to the network. So just to simplify, very simple steps, set of transactions coupled into a block, chain of blocks is blockchain, right? So the idea is every blockchain has its own way of adding transactions to the block, validating these transactions, adding the blocks to the network, and then building the chain. And then how many incentives are being given, how much is the reward given to the validators, the nodes, all of this is specific to the blockchain, right? So the history talks about moving from read-only to a dynamic application where the data was shared, where it was a client-server architecture, where even the Google search history is being stored on data servers on Google. And now we are moving to Web3, where we are saying the ownership of my activity stays with me, right? And the data is secure and the data is immutable. I cannot delete the data. I'll give you one example of an application on the blockchain where we say there is a transaction which is happening where somebody is approving a transaction. That approval stays on the network. That approval as a transaction gets added to the block, and then the block is added to the network, right? The chain. So this network, this approval, this chain or this hierarchy or this list which is being created, it's immutable. Tomorrow, if somebody else takes another approval, another transaction is created. So you cannot go back to an old transaction and delete it. So it's basically, I'll also show you when I display the network and how these transactions are recorded, how a smart contract is executing so many functions, and how this list is being created. So that way we say that there is my unique ID, there is the unique transaction code which is encrypted, there is unique block ID which is encrypted, and the network flows. So there is the history of web, where we move from web 1.0 to 2.0 to 3.0. And then very important, as I said, there's companies who are implementing blockchain at every level. It doesn't have to be only financial transactions or crypto transactions or token transaction. Everything comes down to technology. Again, we are making sure that this is purely not an investment advice. We are talking about technology. We are all technical people, and we need to understand how this thing works. Okay. Okay. So Just to understand a web stack perspective, there are different layers of Web3 tech stack. But if you talk about a Web2 tech stack, where we have clients, your browser, your server, and then the data goes to the server. And on the server, you also have a backup server, and there is a disaster recovery server, and all of this data is being managed by some DB. So your front end could be on the Web2 stack. Your front end could be, let's say, a full stack application with a React application, making some API calls on Node.js, and interacting with any of your database like SQL database or a NoSQL database like MongoDB, and then extracting data, showing your analytics, learning on this data, all that stuff. That's Web2 stack, where you have database interfacing your front end full stack application, right? So in this case, when we come to Web3 stack, we say that we have different layers of the tech stack, where we say L0 is a network layer, where we talk about the most prominent network layer at L0 is Polkadot, where again we will come over and see how this thing is, how Polkadot works, and I think we also have a prominent speaker, Deepak Chaudhary, talking about it later. But to give an example, where layer 0 provides the networking capabilities for different networks. It's a chain of chains. So you basically have an interoperable layer which talks to different networks across different networks, right? So, and then you have layer 1 and 2, which is the protocol layer, where we currently have a Bitcoin, Ethereum, and whatever I'm talking about in terms of React.js, Node.js, Solidity language or Rust language. Please understand, Bitcoin was the first application of blockchain, and it was coded in C++. So it doesn't have to be like you have to understand all of these languages. You can still build on top of these applications. You can build on, as I think Praveen sir was talking about open source, and we're referencing inheriting existing stuff and then building on top of it. I think there is a lot of stuff which can be started from scratch if people do not understand technology, if people do not understand writing fresh code from start. So it's as good as you're writing a hello world application with a public static void main function on Java. So layer 1 and layer 2, we talk about the underlying blockchain architecture, where we have Bitcoin, Ethereum, IPFS. I'll take an example of Ethereum, where you can also write these smart contracts, and you basically say, this is a function of my smart contract, and people, and this is deployed on the network. The moment anyone interacts with the smart contract, that's when the transaction is created and you are locked into it. We'll have a demo of it. Then we have an L3 layer. L3 layer is a layer of human readable languages, where we basically have a development layer. We talk about Solidity language, and I'll show you how Solidity is written here. We have Rust. I think we'll again come to Rust when we talk about Polkadot and Substrate framework, and we also have the Web3.js. We also have an L4 layer, where it's basically a user interface layer where you interact with the network. So for example, you have tools like MetaMask and Rainbow and TapRadar, where the most prominently widely used currently is MetaMask, where you interact with your application. So if you have to build an application, or you're already building an application which you want to say that I want to interact with the blockchain and post this transaction on Ethereum or anything, then one simple way is interface with your MetaMask, configure your MetaMask to the right network, and post a transaction, which we will see. But understanding the tech stack is very important, where you as a developer, you can be a network layer developer, you can also be a protocol, you can also be a front-end developer, you can also be a back-end developer, where you are writing, reading the network for so many transactions in, let's say, Node.js, and then writing scripts to execute more transactions, which can also be done, by the way. So it's absolutely fine if you do not understand programming languages, but just understanding why is always the first question. I always keep saying this, that why is always the first question, right? And then what, and then you have how, who, when, and all those things follow. But please understand, the tech stack is very, very important. And I'll go to the next slide, where I have a lot of sections. So if you look at this where you have the protocols, infrastructure, development tools, and then app enablement. So this app enablement, we talk about different dApps that are also available and how different apps can be created on top of the existing networks, right? So if you look at the protocols at the very bottom, we talk about the protocols, underlying protocols, where we have layer 0, 1, and 2. Layer 1, we basically have all of these applications which we talk about, like Avalanche, Solana, Bitcoin, Ethereum. And then we have layer 2s, where we have Polygon and ZK Sync and Arbitrum. If you look at these sections and you look at these companies, there's so many companies already focusing on one section of it. Now, whether you want to be part of something where, let's say I say, I'm working on identity, right? Or let's say I want to work on node infrastructure, where we are working and integrating and interacting with the network. So for example, different categories here, we have node infrastructure, we have wallet and key management, where we talk about how a wallet has to be configured, how my current application, my web application, my Web2 application will be linked and interfacing to the network, right? So MetaMask, Coinbase wallets, and then you have identity, you have decentralized compute, where we have computation, how the computation will happen on the network. We have decentralized storages, we have oracles and interoperability. Now we have some developer tools where ideally to be a blockchain developer, again, I was saying that you can also start writing code from scratch, or you can also use so many available templates which are available to start creating the contract. There are tools where you can use predefined templates to, let's say, create an NFT or create a smart contract which will perform a certain set of actions, right? So developer tools, tooling utilized across different stages of the Web3 developer journey, right? So you basically start from building it, testing it, deploying it, and you also have a monitoring it, right? So when you build, obviously you are coding it in some format, whether you use a low code or a no code environment, or you also take some predefined templates. Then you test it, you deploy it. Then each network also has like different environments. Like in Web2, we have a dev, QA, and production. Here also, we also have different environments where you can do test. There are different test nets available and mainnet available, right? So when you say mainnet, it is production. When you say testnet, it's a test environment. And then you also have tools for monitoring it. Now there is one section missing in this, which is talking about auditing, right? So when there is a smart contract, a single line of code in the contract written here and there can actually lead to disasters. And we have also seen it in the industry where people face issues with code audits, right? There is memory leaks, there is issues with bridges, there is issues with swapping values, there is issues with so many things. So doing a very strong audit on the smart contract, or it's like a penetration testing on your current application, right? You do penetration testing, you do vulnerability assessments. All of these things will have to be, can also be taken up if people here are also interested in security and vulnerability testing, penetration testing, brute force attacks. All of these things can also be done, which I think we already have it here. We have secure and audit. So there are companies who still do that, and it is a very interesting space where we have a lot of development happening, and we need to make sure that there is very strong crypto audit or a smart contract audit as part of the process. So that's deployment and audit, and then there is monitoring of the network as to how many transactions happen, what is my limit. So for example, if you look at the consensus mechanisms for each of these blockchains, right? And new blockchain companies, they come up with a new consensus mechanism and say, my blockchain is supporting 10,000 transactions per second, right? So 10,000 transactions. I'll give you an example of how this works. The understanding works, right? So if you say that I have X number of transactions happening per second, so the calculation is that you have 86,400 transactions happening per day. and then you equate that to, it's a 1 TPS or 2 TPS, right? And if the network is capable to handle 10,000 transactions per second, you cannot say that I'll move Uber today or Ola today to complete blockchain, because it cannot handle those many transactions, right? There has to be a network which justifies my transactions adding to the blockchain. It has to justify my blocks creating and building my network. So not everything, as Praveen sir rightly mentioned, not everything goes on the chain, right? You have to identify what has to be stored on the blockchain. Very important, like you cannot say I'll post all of my images on blockchain, right? Nobody's going to tamper your image. Yes, if they want to tamper, they can tamper, but let's store the image on a decentralized storage, create a hash of it, and then store that hash on the chain. So there are different ways to manage security. There are different ways to manage data storage, and there are different ways to grow the network. So identifying what goes on the network, identifying what data is stored on the blockchain is very, very important, very, very critical. Just for any business use case, whether it is supply chain, manufacturing, business, any business utility creation, do not just right away jump into including blockchain into it. Identifying even new startups that are coming up, very important that people understand why blockchain, because that's the first question people will ask, investors will ask, why blockchain, right? So there has to be parts of business processes where you justify the usage of blockchain, store that information, or again, blockchain is not a database to store, but it has to have very, very meaningful information as to what is contributing to building the network, right? Again, if you say that I want to store this blockchain on the cloud and I want to create a 5-node network as a private blockchain, it's expensive, right? Any instances you create on your Google, GCP, or AWS, or even Azure, these instances are expensive. So when you build a network, again, you have to identify what blockchain, what consensus mechanism, how is it solving your problem, how will you manage your network, and then so that's again part of the layer 1, layer 2 solution. And then every blockchain will also have its explorer, which we will come to in a few seconds here. But the idea is to identify the right solution, identify the right implementation of blockchain, and use these tools, and even learn from these tools as to how they're doing it, right? And then if you are doing a startup and you want to identify a problem statement, implement the right solution, and then obviously compete with the competitors here. Okay, so a very simple thing I was talking about, a transactions being added to the block, and then a block is basically a chain is created with. So how does a transaction get into the blockchain, right? So a transaction is requested and authenticated. It's a sequence where a block representing the transaction is created. Block is sent to every node in the network. Now, again, as I was saying, and as Praveen sir was also saying, that how the network validates the transaction, right? And how the incentives are given is all specific to the blockchain. So we are basically talking about a transaction is requested. Let's say it's an approval for a loan for $1 million by the bank. We want to record this transaction approval details. Who is the person authorizing it? Who is the requester? What is the amount? All that stuff. It's a transaction. It's requested and it's validated, right? So it's authenticated. Now, once the block is created and it is sent to the node, a node has a node which builds the network, validates this transaction. The node receives a reward, right? So there are again proof of work, proof of stake, proof of identity. There are so many consensus mechanisms respective to each and every network. And I think over the next few weeks and months, I think there will be very, very detailed sessions around how the networks are managed, and how even from a poll coder perspective, we will have understanding of how the network grows and how you interact with different networks. So the nodes who are validating the transactions, they receive a reward, right? In any format, it could be a native currency, or it could be any other format for a reward, and then it is added to the chain. right? And then an update is sent to all the other nodes saying, okay, this is what is being, this block is already added and we are good to go. That is when the transaction is complete. So I have another very simple explanation of how a Web2, from a technical application perspective, how a Web2 application works and how a Web3 application works. If you look at a Web2 application where we have a browser, any application where, let's take an example of a property management website where I'm listing my property on, or I'm looking for a property, and then it's basically a front end. There is internet, there are APIs, there is an API call from the front end. It goes to the server, it pulls all the information, it basically makes a request, and then there is an API call for an application server, and then there is a database on the server. It pulls the information back and then shows me like a listing of properties, or my properties, my accounts, email, password, OTP based. Everything is all Web2 based, where we say that it's a client server architecture where we make a request, the browser, or when we say we, the client browser application from the front end makes a request to the server, a server responds, and then data is given back from the server application, which is again connected to your database server. This database can be anything, like SQL Server or Oracle or any traditional relational database. When it comes to Web3, where we say that the same thing, where, okay, there is a client application where I'll give you an example of this application where we're saying there is a front-end application, and a very simple application could be that there is somebody, you're trying to buy a mobile phone, right? And you buy a mobile phone with an EMI, okay? And when you buy a mobile phone with an EMI, you say that, okay, I want to, this mobile phone is, let's say, worth 1 lakh, and you want to buy it in EMI for 6 months, and you split this, you do a down payment of whatever, 10,000 rupees, and then you say 15,000 is my cost every month, right? Now, what we are saying is this EMI of fixing the amount, the EMI every month, and the person who will be paying it is part of the smart contract. And you put this logic into the smart contract, and every time you pay, your transaction is recorded, your initial amount is recorded, your transactions, every payment is recorded, and a history is recorded as to when you have paid and what you have paid. And the most impressive part is it's not stored on one server, it is all part of the network now, right? So you have a client browser front-end application, right? It makes a server request, it at least loads the front end of, okay, this is my product, this is my information, this is the amount, this is how the split of the EMI would be. And then you say, make an API call. Once you make an API call, it also interacts through this RPC request through the server, and then interacts with the network, and then posts this information saying that when I say buy and I make a payment, it also triggers and initiates a transaction saying that I want to interact with this smart contract, execute a transaction with my particular wallet address, my unique hash ID, and say 10% is being paid, 10,000 rupees, and then 6 months we'll pay 15,000 rupees each. And then all of these things get recorded. So next time when I come back, I will also be saying, I can actually see how 2 payments are done, and then your balance are there. All of this is recorded. It's not centralized, which means I cannot go and edit it. Somebody cannot go and edit it. So this architecture, this interaction happens through all of these remote procedure calls, where you interact with the blockchain and then retrieve information based on that smart contract, and then show the balances of when you paid, how much is paid, and how much is the balance to be paid. Okay, give you a small glimpse of, okay, I would want to just give a little background of what MetaMask is. Okay, people do not know it. It's a 3-minute, 5-minute video on YouTube as to what MetaMask is. It's a crypto wallet and a gateway to blockchain apps. Let's not go into crypto transactions and this and that and all, but let's understand how this MetaMask is used to connect to different blockchain applications, blockchain networks. So I already have it installed, and the process of installation is pretty straightforward. You just have to download a Chrome extension, If I go to here, I see a Chrome extension. It has 10 million downloads. A step-by-step guide is mentioned. An Ethereum wallet in your browser. MetaMask is an extension. So the way this extension works, it's basically a interface for you to connect to the network from your browser application. Okay, so MetaMask also lets you create and manage their own identities via private keys. So like you have your email, username, and password, here, when you create an account on MetaMask, you will be getting a private, a public key and a private key. Public key is like your email address, and private key is like your password, right? And there is a pass phrase, which is a recovery phase for your wallet. Okay, so very simple exercise. Just go understand what it is, how it is working, and then you basically get this. You see my cursor here. It has this. Let me lock it. When you first launch it, you see this something called as Ethereum mainnet. As I said, your test nets are your test environments. Your mainnet is your mainnet like production, and then you get this. So if I go here, I'm basically shown this. Now, this is one interface where if you look at this, it has account details, view on Explorer, connected sites, portfolio view. It's and here, if I say Ethereum mainnet, Linea mainnet, Avalanche network C chain, and I can also have more test nets, or I can add another network. So tomorrow, if we find another network, we can actually add that network to the MetaMask. It has to be compatible with the how it network has to be added here, and then you can actually see that, and then you can interact with this. So now, if I want to interact with my Ethereum mainnet, again, Ethereum is a layer 1 protocol. Your smart contracts can be created. Your smart contracts can be created and deployed to the Ethereum testnet and mainnet, and then you can interact with these transactions to. You can create transactions to interact with your smart contract, which is deployed on Ethereum. I'm just trying to keep it very, very simple. The idea is to understand the technology. The idea is to understand how this thing works technically. We are not right now coding into what is smart contract. We're not coding into how Ethereum blockchain is built, right? So we are understanding from an end user perspective, not from an end user, from a developer perspective, how you interact and how you go and see your transaction, right? So if you look at this, you look at here, I say copy etherscan.io. Now this etherscan.io is the official Ethereum blockchain explorer. It basically talks about, again, what is the price, what is the latest blocks which are created. If you look at it, these are the blocks. Each block has so many transactions. And then you have this latest transactions, pending transactions, view blocks. You can also do something called as forking. And there are different types of forks, but we do not want to go into the forks right now. Then you have tokens, you have NFTs, you have resources, you have charts and statistics. You have top statistics, you have newsletters, and then there are APIs also. So if anybody's interested in making an API call to the Ethereum network to read data from those one particular smart contract, you can also make an API call using the interfacing libraries available. So if I, from MetaMask, if I take my public address, now this is my public address. Now let me just here go and create account. So when I say add account, I'm saying CEP, August, create. Now, if you see this on my MetaMask, for my account name, it created a new public key. When I select this and I go to etherscan.io and I paste it and I press enter, it basically says that if you look at the URL, it says etherscan.io/address. This is my public key. This is my account. This is my email address, or this is my account for any of my activity. This is encrypted. You cannot like decode it to derive it to me coming and working out of India, from Hyderabad, or from wherever it is. So here it will basically list down all the transactions, all the token transfers, all the comments relevant to this particular address. Now, this is a naming convention that is being followed by Ethereum. But when you go to Polkadot or when you go to other networks, they have their own naming convention for the public keys, right? So I'll take an example of one. Let me just go back to MetaMask here. Now, if you look at this, I have 0 Ethers in this public key. This is my fresh account. If I have to give this to somebody, I can import tokens, I can refresh this. This is the key that I'll be using as a public key, right? And then I can list down all the NFTs here. This is the new version of MetaMask. Earlier, there was a different version, but now we have activity. You can actually see all transactions happening. So let me go to one account which already has a transaction. Let me see if I have something in my other accounts. Okay, I do not, but I have a wallet address. Okay, I can again go back to Ethereum, etherscan.io. This is official blockchain explorer. Here you can actually see all transactions. And let me show you one transaction before I go to that one, right? So here, let's say I click on this latest transaction. Okay, now here, transaction hash. This is a uniquely generated hash code. The status is success. This is the block number that it belongs to. This is the timestamp where it says it's 24 seconds ago. All of this naming convention here, and the time zone format is UTC time zone, which is 5.5 hours behind India. Now, what this says is that there is a from account and there is a to account, right? And this is the value. So what has happened is from this account, from a particular wallet has gone into this account, and the value that has been transferred is this. Now here, if you look at the transaction fee, and there is a gas price. So every transaction on Ethereum requires a gas fee, right? Again, when it comes to proof of stake, proof of work, and there is how the gas fee is derived and how the gas fee or how the incentive is distributed is again specific to the different network, which will come in the following sessions. But currently we say that this transaction hash represents a transaction from account to account. And then there are more details, right? There is burnt and transaction saving fees, gas fees. There is a minimum and a maximum. There's other attributes that we have, and there are different attributes as part of a transaction called nonce and type of transaction, and then position in the block, right? So the idea is to understand the transactions, the features, the attributes, and all of this is again belonging to a block. If I click on the block number, it has all the other details about block height, their status, their, the difficulty level, and the number of transactions in the block. Some of the networks, there are some networks in the market where there is only one transaction in one block. But here in Ethereum, we have multiple transactions in the block. Okay, so I'll give you another example of something which is very, very technical to us, where we talk about smart contract, and we want to see what is a smart contract. So I have a wallet address that I have. Now, this is very simple. If I know your email address, or if I know your public key, I can actually go and check everything as to what you have done in the history. Now, for example, this wallet address, right? This is, let's say, 81 ending with 0x AF7 and then an 81B1. I can actually see what this wallet has actually done in the past, right? This is my transaction history, right from 529 days ago. I mean, I can also say view all transactions. I scroll down. I have 541 days ago a history of what has happened on this wallet account, which is bringing me trust, which is saying that, take a look at here, right? On this day, first, there was an unstake method. Then after 3 hours, this happened. After 3 hours, after this, there was another transaction. and then there is an unstaking which happened, and there is a transfer which happened. So all of this is giving me, one, trust in the system. Two, it is giving me a history of what has happened on the network, right? I'll give you an example of this function, this transaction hash, right? A total of 57 transactions have happened on this particular public. I don't even know whose wallet account this is, and I don't even know that. I don't even have access to this account, like a private key or a password or an email password or an OTP based, nothing, right? So here, when I click on this transaction, right, what this says, as a transaction on the network, it says that, okay, this is a transaction hash, a uniquely created hash ID. Status is confirmed, right? And this happened April 10, 2023 with the UTC timestamp. It says that there was a NFT token. Again, NFT is another section where we have a lot of use cases. We talk about Web3, decentralized, how NFTs are used in metaverses, and how these tokens are actually created on the network. There are different protocols which it follows, and there are different types of NFTs. All of these, when you say NFT, it is a smart contract. It is a token, right? So the idea is here, what it says is that from this wallet, there has been an interaction with this address. Now, if you look at this, there is a small icon here called contract, which means that this wallet address or this email address or this public address has actually interacted with this contract. Okay, so when I click on this contract, again, earlier in my personal capacity, when I launched it, it was showing address, but now it talks about contract, right? Now, this is a contract address. Again, we can actually find out who created this, but here we have a contract address. Now, this contract has so many functions like stake, unstake, stake, unstake. Again, this is a very specific feature to a use case where we are saying that whatever NFT you have, you can actually stake it to claim more rewards, right? So this contract has currently 0 balance. If I go to the tab called contract, I can actually see the code here. Okay, now this is Solidity code. This is, again, no rocket science, very, very standard code, very easy to understand. You don't have to be a programmer to do this. A very simple course on how to create a smart contract in Solidity can help you understand this. And there are so many templates available to create it, right? Again, not easy as it looks like, but deep understanding of how these things work is required first at the overview level, and then you go into each function. It's basically like a class with so many functions, right? So if you look at this, there is a contract, there are some import libraries, and then you have functions, and then let's say this function, and function has input and output, right? So function unstake, function stake. So sorry, here you have structures defined on the top, then you have function stake with input parameters and then output parameters, and then you have unstake function. Now, what it does is that, if you understand the logic or just follow through the algorithm, it basically says that, okay, transfer the function, transfer, right? First, it checks whether only owner can stake. 2, it checks whether there is an invalid collection. So all of these checks are required, and then you basically do a transfer, right? So it depends on what you're trying to code in the smart contract, whether it is staking functionality, whether it is loan approval functionality, whether you're trying to buy a property and somebody is putting in, like, a buyer is coming and a seller is coming, and then basically you agree to some terms and conditions. All of that can be put into this contract, and this will be publicly available on the network. And when the transactions are executed, all of that is visible with respect to public IDs or hash or public hash IDs. Then you have different functions, and then you have different contracts, right? So Solidity contracts have an extension of .sol, and then you have context, address. So you run these contracts. You build the smart contract, deploy the smart contract, and test the smart contract and monitor the result. This is the sequence that we had in the earlier slides. So the idea is, once you understand how a smart contract is, a first version of Hello World smart contract is created, you deploy it to the testnet, you understand how a transaction is interacting with it. So when I am executing a transaction using this, it says that I am running this stake function of my smart contract. It has executed at this particular timestamp from this address to this address, and this is my transaction fee, right? So this is how a smart contract is coded. You don't have to be very strong. Again, for example, if I want to test a function here, I can also do a test of function here. So for example, I can click on read contract, right? I have to connect to the wallet, connect to Web3, which is again connecting to a wallet. So I'll show you how I can connect it here. So when I'm choosing my account here, I created this CEP account, which is ending with 76AB. When I say connect to wallet, it shows me a pop-up saying, please take note, this is the beta version. I say, okay, and I want to connect to MetaMask. When I connect to click on MetaMask here, it basically connects to my last open account on my Chrome extension. So when I click on it, this here, it takes an authorization, say next, connect. You see this, connected. So now when I run this, when I test this accepted collections or get status, then I'm running this function with this account, with this wallet address, which means that I am testing it. If you want to, if I want to check my EMI balance, I will connect my wallet here and then check what my EMI balance is. If you want to check it, you connect your wallet here and then test it. You can actually test your smart contracts. You are testing the functions of your smart contract here, right? So get number of NFMs staked by collection by user. So staked by is an address, collection is an address. So if I query, it'll give me the by collection, how many NFMs are staked. So the idea is that you create, which is build, you deploy, you test. Then if I have to write something, right, I can also do a write where I'm connecting. I have to be an owner to change some parameter settings. So I say that, oh, I want to do a EMI setting for, initially I had a 6 months plan to give it to my people to pay, my customers to pay. Now I want to change it, right? I want to give 3 months grace period for people to come back and pay their debts. So when I deploy the smart contract, I am the owner of it. Now, if I had to change the value, let's say pause or transfer ownership or any such function name, your naming convention defines a function name. So I have to connect, I have to be an owner of the smart contract. I connect it here. I go and execute the function, go to the function like this. And then I say, instead of 60 days, I say 90 days. And then the value on the smart contract is changed, and that will be reflected for everyone. So the idea is to manage your contract, your smart contract here. It has a different version. It has a compiler version. It has a function where you can read and write contract. When I say read and write contract, this is testing the functions inside the contract, right? And then if you go to transaction and you go to this particular transaction, you can also see the logs here. When I click on the log, it says that first it called the transfer function, then it also has executed the NFM stake function, right? So it talks about this, it talks about the input parameters, it talks about what it has done, and then there is decimal and hexadecimal. Okay, so that's basically an understanding of how Ethereum works in terms of all the transactions, how a smart contract is deployed, how a transaction, when it's executed, it's executing a very, very specific function of a smart contract. And then to create a smart contract is also not rocket science, but you have to understand the very, very specific techniques of how it is managed. Okay, so I'll give you another example of Avalanche. Let's see, Avalanche. Oh, sorry. Okay, it's called Snow Trace. So like Ethereum's blockchain is called etherscan.io. Avalanche is again another network. It's called snowtrace.io. And I'm sure we'll have Polka.assembly and other things covered by Deepak Chaudhary sir going forward. But again, if you look at how this is exactly a little replica of how these different transactions are happening on the network, how the same things are being executed, how logs are being executed, and how different functions are being called. Right. So here, if you say this example of an approval, this talks about that some particular person has given an approval for some other person, and that transaction hash, this hash is being stored here, which basically represents that some activity has happened and some authorization has happened. So going back to Ethereum and going back to the slide, we are saying that we now are in a shape to understand Web2 to Web3, and we say Web3, we have how to interact with the blockchain, how my current application is working with the application, how my current browser-based, client-based application is interacting with my MetaMask to go to a smart contract execution and smart execute very, very specific functions of it. Not difficult, very, very straightforward. You need to understand the basics, right? It's now time to go back to the basics, basically. So for me, I'm going to go back to the presentation, talk about use cases of Web3. Again, I'll keep it simple. DeFi protocols, DAOs, creator economy, user privacy, metaverse, blockchain games, no censorship, and content management. Each one of this is itself multiple sessions. We can talk endlessly on it, but we need to make sure that we define some method to the madness, right? So the idea is we understand what Web3 can do. We understand what we have also seen metaverses example where Facebook was trying to launch a metaverse. I think they're still working on it with funding of $10 billion on how metaverse will work and how NFTs as objects which define the ownership of items to be used. A better example of it is these companies called Dana, I think Mana, sorry, Decentraland. Okay, so if you look at look at this metaverse where you can play around with it, you can create your avatars. These all avatars again have all of these accessories. All of these accessories can be these are all NFTs owned by respective people, and then play around with this where you can create environments. You can incentivize people to visit your spaces and then start exploring. There are a lot of use cases on metaverse, but the idea is to understand how this fundamentally works in terms of defining ownership of objects to people. And again, if I talk about MetaMask, my public ID, again, if I have to interact with, let's say, Decentraland, I would again connect to MetaMask. My wallet is there. It will show me my IDs if I launch here. And if I go to NFTs, it will show me my NFTs, whether it is a cap or it is a hat or it is my gun or it is a sword, any of those activities, any of those NFTs or art pieces or creative pieces will be linked to my particular wallet address, and then that will be used to interact with the metaverse objects. Okay, so a lot of companies are adopting. I was talking about companies like Starbucks, Disney, UNICEF is doing heavy in terms of supply chain. We have luxury brands here. Sorry, I don't have the names here, but if you just Okay, Louis Vuitton, Mercedes-Benz, OTB, Prada, all of these companies are in a process of implementing blockchain to address specific use cases in their process of either manufacturing or supply chain, or even making sure that the item reaches the customer with full trust. So that said, I think I do not know how much time I have, but again, to summarize this, there is lot to learn. There is a lot of things that can be done. Blockchain as technology is picking up very heavy. The shift is on. We do not talk about currency and trading and other things, but we talk about the technology. So transactions, consensus mechanisms, smart contracts, building trust, implementing business processes to include to build trust and to make sure that we are not manipulating data and disturbing and disrupting the processes around it.
There are, dozens of questions. Let me just ask a couple of them, which I think most of the people might have in the mind. So let me take one question from Partha Oja. He's asking, when we own and modify a smart contract, then how does the original contract remain unchanged for other users?
So one, when you change, so there are two things, right? One is what are you trying to modify? One, you cannot modify the smart contract in terms of once it's deployed. There are ways to upgrade a smart contract. There are upgradable smart contracts also possible. But once a transaction is done, you cannot change those. For example, I was talking about limits being enhanced. I want to extend my limit for EMI, right? Once I do that, that's applicable for all the wallets or all the account holders which are linked to my smart contract. So for example, if I have 10,000 rupees as my upfront money, and then I have 15,000 rupees I paid for 2 months, and now I'm not paying it, but the company has given an extension. Now the new revised end time is updated for all people. So when you go into the smart contract on Etherscan and then you read function and say, execute the function of how much time I have left, it will say you have another 3 months of grace period time. So the parameters values are being extended here, right? So you are saying that I'm extending my end date. I'm extending my incentive. I was initially giving 10% discount. Now I'm giving 15% discount, right? So people who are, the thing that we're trying to modify are limits and extensions and incentives and numbers, which will basically say that my number is extended or changed. So to answer that next question, I see another question here which says, didn't it require agreement from both parties involved in the transaction? I'm assuming this is related to the change and the modification. One, if you change anything, see, I'm the owner of the contract, right? If I'm running this EMI scheme for my customers, I'm giving an extension to them, right? Now, it will be bad on my part if I'm changing that timeline and I'm saying stopping everything. It's a loss to me. Why would I even do that? I'm losing customers, I'm losing trust, and I'm ending the process, right? So in such scenarios, for you to survive, we're trying to build a process and we're trying to build trust to the people, right? So if I'm saying you have paid, sometimes people say I have paid, I have not received an answer, I have not received the confirmation. We are saying it is a network. The network confirms your transaction, right? So with your public hash, which is interacting with the smart contract, we are giving you confirmation that you have paid for 2 months. So one, if I am the owner of the smart contract and I'm executing a function, then it applies to all the participants. If I make an extension to 1 month and then you come back and then you execute the function, you will be shown the new timeline for it. Hope that answers the question.
Yeah, thank you, sir. So let me just take another question. Ujjwal Sharma is asking, MetaMask is a crypto wallet, and sir said it's a gateway to different platforms. How? Didn't get it.
Yeah, so as I said here, I'm going to show this. I'm still sharing my screen. So if I look at this one, right, it's a wallet. Now, when I am connected as a wallet, I can actually store any currency here. That is right. But if I'm interacting with this, so if you see this, I'm currently connected to Ethereum mainnet. And then this is my public address. Let me see if I can launch this application that I have. Okay. So it's an application. Let's see, buy.nitro.network dashboard. Come on. Okay, so this is an application, right? Now, this is again configured to Avalanche, right? So when I click on this, I'll show you what it means. Okay, I'm going to change this to Avalanche network. Okay, now I have that EMI application that I was talking about, right? So buy with EMI. Okay, now if I scroll down and I say, how many do I have right now? 0, because this is my fresh account. I have 0 balance, right? So if I have 0 balance and I say connect wallet, what it is doing, it is connecting to my last connected wallet, which is this 76 EB. Now this application currently is, this end application is connected to the network, and this is my public key now. This is my email address. This is my username, right? Now, if I have to buy, I scroll down. I mean, they're not selling it right now, but if I buy something here, it will actually, if you look at these terms and conditions here, right, a minimum of 10% is required to be made for the EMI to be started, right? There are some rewards if you purchase it, and it says if the NFM paid with the EMI plan is not fully paid within 100 days from the date of purchase, there will be no minting and no such incentives and all that stuff. Now, these logics are coded into the smart contract. Okay. Now, when they are coded in the smart contract, I am basically interacting this through my account here, which is MetaMask wallet, and an interface to interact with the smart contract on the network. So the idea is, it's not just a wallet to store my currency. It is, but it is also a way to interact and execute a function, which will be reflected in the activity. So when I go to this, take this wallet address, right, and then go to Etherscan, and then, or go to Snowtrace, it will actually show me that activity here, which is what I have shown here, which is what I've shown in the earlier one. I had it closed, but which is this, right? So we are saying that this is the activity that it is doing. It is doing it through my MetaMask. I'm executing a transaction, a purchase or stake or anything, using my public key on this. So to answer that question, yes, it is a wallet and it is a gateway to apps. It is a gateway for us to connect my front-end application to interacting all the way, interfacing to the blockchain through my MetaMask to the network, and basically executing a function on my smart contract.
Yeah, good evening, everybody. It's pleasure to be here with all of you today. My name is Deepak Chaudhary, and I work as an dev advocate at IBC Media. For the past few years, I have been deeply involved, engaged in the development within the Polkadot network. Now I'm excited to have the opportunity to share some insight with all of you as we deep dive into the CEP sessions. But today, I'll try to give you a basic overview of Polkadot and see how the things work under the hood. Right. First, let's see what is Polkadot. Polkadot is a protocol that connects blockchain and allowing values and data to be sent across previously incompatible networks like Bitcoin, Ethereum. It also designed to be fast and scalable. It is this is a typical definition of Polkadot, and we'll understand more in the coming slides. So next we have why Polkadot. If we have already so many networks in the market, so why do we need to build on Polkadot network? So let's explore the features which Polkadot provides us. In that, first is it connects network together. Polkadot helps us in connecting more than one network with each other. Let's say I have one chain and any one of you have one. So traditionally, we can't communicate with each other, but in Polkadot, we can communicate with each other, also transfer any type of data between them. Right. Next is it provides a high scalability. So traditional blockchains have only one chain on which all the transactions perform. And let's say a lot of people come and do some transactions, then obviously we will face some traffic at that point. That time scaling would be an issue. So Polkadot exactly solves this issue by sharding. So these shards, we call it as parachain. Polkadot allow multiple parachains to run concurrently and process transactions in parallel. This distributes the load and increase the overall network capacity that improves the scalability. Next, we have shared security. A Polkadot relay chain provides a shared security for all the connected parachains to maintain its security mechanism that enhance efficiency and reducing the complexities. Yeah. Next is it provides the customization. If we take an example of Ethereum and other layer ones, so we don't have any access to customize the core functionalities of the chain. But in Polkadot, we have full access to customize our chain as per our need. Next, we have on-chain governance. Let's take an example again of Ethereum, which stores data, some data off-chain and some data on-chain. Because of this, there is no full transparency here. But in Polkadot, we store all the governance data on chain. At last but not the least, it provides forkless updates. Some of you might know what is forking. Let me give you a brief overview of forking. Let's understand by an example. If let's say if there would be a big upgrade in the chain and some people might not want to adapt the new changes, then the chain will be divided into two parts. So this is called a hard fork, and that's not happen in the Polkadot. Till now in Polkadot, around 200 forkless update were successfully done. Okay, let's understand the architecture of the Polkadot. In the middle, we have Polkadot chain, we call the relay chain, and you can see a ring. There is some white blocks there. We call it as these are slots. If we need to deploy our chain on relay chain, then we need to win a slot in the auction. Currently, we have 100 slots, out of which 40 are already occupied. And if you can see this tree-like structure, these are the parachains. What parachains is, if we build our custom chain and we deploy this chain on the Polkadot, then our chain is known as parachain. you can also see a collators. What collators do is collators collect the transactions from the parachain and pass it to the validators. You can see here there are some validators here. So validators will validate those transactions, and if the transactions come out to be a valid, then these validators pass the state of that parachain to the relay chain. Okay, so let me show you one thing. As Avinash was shown some like Ethereum Explorer and Avalanche Explorer. So this is the, we can say, Explorer for Polkadot.js. You can see these are the blocks which is currently finalizing, right? And these are the events. These are the events which is currently happening at this number of block. There is a transfer of balance from this account to this account, and how much this is the amount. And if you want to like know the block details, you can go ahead and check the detail of the block here, right? Then you can see all the parachains here. So these are the parachains which is currently live on the relay chain. And if we see the Kusama parachain, so these are the Kusama parachains which is live on Kusama. Kusama is like a canary network for the Polkadot, right? And if we want to see the validators which is currently active, so we can see here also. These are the validators which is currently validating the nodes, right? So you can see the democracy. Democracy is like if we need something, let's say I'm doing some NGO work and I need some funds from the Polkadot. So what can I do? What I can do is I can raise a proposal, right? And proposal will shown here. And if I want to support that proposal, anyone can support that. I can endure that with some amount of dot and endure that. After, if this proposal is accepted, then this proposal will reflect in the referenda. In referenda, anyone can come and vote on that, whether aye or nay. If more than 50% of the vote comes into the aye, then this referenda will dispatch, or we'll get the fund for our NGO. These are some other technical things. Chain state extrinsics, will cover this in the coming sessions. So what is extrinsics and what are the chain states? When we develop our own chain, we'll cover these all.
All right. So I think I'll start with Ujjwal Sharma's question, which says validators are the miners here, right?
Yeah, kind of. Validators validate the transaction, but for parachain, miners are collators, and for relay chain, validators are miners.
Okay. Then we have one question from Sujal Sharma. What if no one is mining? Then what will happen with the validation process?
I think this question is also come earlier. If no one is mining, then what will happen with the validation? So, sir, can you take this question?
Absolutely. So one thing that we have to understand that in the proof of work world, we call it miners, and proof of stake world, we call it validators. Okay. Now, when any new blockchain gets formed or gets created, they need validators to validate the transactions and create blocks, right? So now the question is that if there are no validators in any blockchain, then of course blockchain will not work, because it is very, very essential for validators to be there who validate the block and create the blocks to make blockchain, right? As a blockchain person, it is very important for the blockchain creators to have enough incentivization mechanism built into the process so that people are willing to come invest, by being a validator, by staking their, currency, and and be willing to participate in the validation process. That is very important. And I guess all the blockchains, when they get started in the beginning, they have this problem. They want validators to come and do that. So I think it's a genuine question. But then I think what I have felt that if you have got a genuine, if you are solving some problem genuinely, and if if people feel getting incentivized, validators do come, because this is a profitable business for them. As long as they are being able to make money from your system, they will come. Yeah, Deepak.
Yeah, thank you, sir. So, Deepak, what I would request you to do is basically just go through the Q&A once, and let's address a couple of questions that you would want to prioritize.
Yeah, let me
Whether you can start
address some.
you start from the last, because there are questions from Polkadot system there.
Yeah, sure. So let's take what is the main function of relay chain. Relay chain, as Avinash sir said, it provide a platform for other chains to build on that, right? It basically provide a platform where any chain can come and communicate with each other. So the main function of relay chain is that. Implementing other networks mean like Ethereum.
Not like Deepak said here, that the relay function is the center of the system to which all other parachains are connected, right? So you can just think of a hub and spoke model basically. Yeah, Deepak, please continue.
Yeah, thank you, sir. Why can't we send directly to relay chain? I think why can't we send transactions directly to relay chain? We can't do that because I think, please elaborate your question. I think we can do something on relay chain and parachain and both. If you can just explain your question a little bit.
So, while you explain your question, see, you have to understand the structure architecture here. The architecture goes like this. Relay chain is the center, the brain of the Polkadot system, which allows different parachains to connect to each other, right? And also provide them the security that Deepak Chaudhary talked about. Okay. Now you are required to put your business functions, business applications, or business. There is a term called app-based chains. Okay. So the idea here is to have your chain which you want, and you can customize your chain like Chaudhary talked about. You cannot go and change the infrastructure level core function of Ethereum, for example, right? Because you are not allowed to do that. But here you can create your own chain. You can have your own consensus mechanism. You can have your validators. You can define your own rules all on your chain, which will be hosted as a parachain, and you can have your business function deployed on that chain, right? So the users are expected to interact with these parachains essentially for their business function, right? Chaudhary, I hope I am doing justice.
Yeah, perfectly.
Go
First, now we have one question: how parachain works? Parachain, as Praveen sir said, is like our custom chain. Custom chain, we can think of like if we want a smart contract between two parties. So what we can do is we can build our chain, and this chain will act as a parachain.
So you have to also think of one thing. Polkadot is also considered to be, or said to be, a layer 0 chain. Okay. Now Avinash also talked about that. So when we say layer 0 chain, it really means that it provides an ability to other parachains which are considered to be layer 1 chains to interact with each other. So it's a foundation to various other layer chains, either parachains or the external chains to talk to each other. And that's where it becomes one level below layer 1. And that's where it's called layer 0 chain. Yeah, Chandra Prakash Sharma, I think, let me take that question, Deepak Chaudhary. Difference between ICP and other blockchain. Okay. So now, if you recall, Avinash was talking about, okay. Yeah, so the ICP is called Internet Computer Protocol. This is a protocol which provides an ability to people to spare or to share their compute, what they have at their disposal, which is not being used, and earn money and participate in this protocol, right? So basically it is decentralized compute, and I think to some extent decentralized storage also. So what really has happened, that by coming up with this model, this is, you can say that this is a decentralized cloud where people are coming together, like you, if you know IPFS or decentralized storage, what happens there? Everybody who has got some storage at their disposal which is not being used, they participate in that protocol. And then there are things like Filecoin, Arweave, and all of those, where you go and participate into that protocol, contribute by storing things on your computer, and get rewarded for that. Right? That's the ICP. Now, ICP is, you can say that is kind of blockchain, and other blockchains, Ethereum is a blockchain, layer 1 blockchain, where Ethereum has its own purpose. Avalanche, Solana, all these people came and they started with some objective as to solve some of the key problems that Ethereum was facing, was not able to solve in terms of throughput, in terms of speed. Correct? So you cannot just say that difference between ICP and all blockchains which have been created, they have to be created with a purpose. You cannot just go and say that, I'm creating a new blockchain because I feel like doing it. No, you have to have a purpose. You have to have some solution to the problem which others are facing and they're not being able to solve. I hope, I'm able to give some points to you, Chandra Prakash. Yeah. Deepak Chaudhary, please continue.
I think I have covered all the questions regarding the Polkadot. So we can take general questions.
You can continue moving up, and if you need me to answer, please let me know.
Yeah, okay. So can we start from above?
Please continue.
One question is, how do we select the node in the network?
So this question is little not clear. So what really happens, and let me explain to you the process here. So what happens when you want to participate in a blockchain as a node, what you essentially do is that you go and run the software of that blockchain into one machine, right? Then you become a validator node. Now, you can be a node, and there are different types of node. I will not go into that right now. But if you are talking about the question that, when how do you access a node? So basically, to be able to transact on a blockchain, or to be able to send your transaction to a blockchain, to be able to read some data from the blockchain, you need to go via a node. Okay. So for that, what you can do, you can create your own node. Means you have to rent a machine, you have to have a system, and on that system you will have to go and run the software of that particular blockchain. Now, different blockchains have different types of requirement of node. Some blockchains tell you that, okay, you can run your node on a simple machine also, but there are some nodes, some blockchains where running a blockchain is a very, very difficult task. You need to have a very hi-fi system. You need to spend a lot of money in that, right? So what people do, there are so many node and infrastructure services companies run the nodes for different blockchains. Okay, so for example, I'm a company called Alchemy, or I could be any other company. So I will run the nodes for different blockchains, and I will be exposing the access to these blockchains via my node through that node as an API. Okay, or the remote RPC call, whatever you call. Okay, So what happens in that process, that if you really want to go and access a particular blockchain, you will go and hit the node of that blockchain being run by this company. And then that company, that node will forward your request to the blockchain on your behalf, right? And that company will charge you some money per transaction or whatever basis, right? So that's how you see the relevance of node in blockchain.
Yes, sir. Next, we have Web2 apps uses user data to show targeted advertisement to earn. What about Web3? What is the source of income?
So again, so as a business, every application, Web2 or Web3, they need to have a monetization strategy. So how do you earn money, right? Now Web3 economics is little complicated, where as an application you need to have, first of all, you may have your own token or currency, or you may not have, right? In Web3, for example, if you are a gaming company, I'm giving an example here. If you are a gaming company, and if people are coming and playing on your game, then you may charge a fee to people to be able to play on that, right? So that could be one way to monetize. Second way could be that if you are a company which is a real estate company in showing Decentraland or Sandbox or these kind of gaming metaverses based systems. The Web2 is a way of doing business. Web3 is also another way of doing business, but the monetization strategy still remains very similar. Some additional angles being brought into Web3 with respect to which is called token. You have to go and read some white papers and try to understand what really is the tokenomics usual. Try to spend some time on that. You will get some more perspective on that. Deepak?
Yeah, thank you, sir. For every single transactions and interactions, we create a block and add into the network.
No, Joel, that is not correct. So every transaction, you don't create a block. What you do is that, as I was telling yesterday also, I am sure you would have attended yesterday's session. So what happens when these transactions are coming from various people, various users, when they sign transaction, like Avi was showing, sign the transaction using your private key and send that transaction to the blockchain, right? And all the nodes, they kind of go and receive the transactions which are being shared with them through gossip protocol, right? And every node will maintain its own. Transactions are being picked up by nodes. Say, for example, I am trying to create a node. If I am the person who is chosen to create the next block, right? There are many blockchains which work like that. So when I am being given the responsibility of making the next block, I will go and select the transactions from my mempool, and then I will be putting them in the block. And one block may contain several thousand transactions, for example, and all those transactions will form the block. And if I have not done anything foul, then this block gets accepted, and then all these transactions get included in the block. So it is not true that one transaction, every single interaction. No, all these transactions keep coming into the mempool, and as and when they get included in a block, they get removed from the mempool, and this information goes to all other nodes that, look, this transaction I have already included in the block, so please you also exclude from your mempool. So that's how that also happens through gossip protocol. Yeah, Deepak, please continue.
Yeah. Is there many pre-built solutions in blockchain domain? Will this domain get affected by generative AI and ML in near future with adoption of automation? I'm asking this as I read some statistical data released by OpenAI in an article comparing ChatGPT 3 versus ChatGPT 4.
I think, yeah, so my perspective on this is that all these technologies are helping each other. In fact, there is a lot of utility of blockchain in machine learning also. There is a lot of applications of machine learning in blockchain also, right? I mean, so for example, machine learning is based on data, right? Whether it is ChatGPT or any other, machine learning based tools that you see in the industry today, all of them work on the data that is being fed, and accordingly only that that blockchain provides you the answer, correct? Now, if the source of data is not authentic, then the response you are getting from these tools also is not reliable, right? So blockchain could prove, and I think I saw some question coming from someone that, how could blockchain help in this case? Blockchain could help authenticate the data source so that the outcome that you are getting from, blockchain, so from these AI tools, they are authenticated and they are reliable, right? So there are, all these are various tools which are progressing at the same speed with various, outcomes and benefits, and all of these interact with each other. I think this is a very, very larger debate. Unless Avinash has something to comment on this, I would, stop it on this question here. Yeah, go ahead, Deepak.
Yeah, sure. Who are the members of a network? Like, what is the difference between avalanche and a linear network? What does it mean? Everyone has to approve it?
No, I think again, so this question is a little ambiguous. So as I said earlier, and I think we should be very clear about it, there are different blockchains. These blockchains could be of different types. They could be layer 1, some could be layer 0, some could be layer 2. All these blockchains, they function with a different purpose, correct? And in fact, some blockchains also have very, very designated or very, very, pointed intention of being created, right? So all these blockchains have their own nodes. So understand this infrastructure, guys. All these blockchains, they have their own nodes, validators. Those validators, they validate the transactions, they create blocks in their own way, right? I could have my own mechanism of validating. You could have your own mechanism validation. But again, at the end of the day, all are validating as per the ground rules for that blockchain, and blocks are getting created, right? So there are different blockchains, and all of them are different, right? So it's not like everyone has to approve it. So all of these blockchains are isolated world. If you really see, Ethereum is a world which has got its own, concepts, which have its own rules. And on this Ethereum network, there are thousands of applications or dApps which are running on this Ethereum. Similar to that, Solana is a different network which has got its own validator nodes. This ecosystem is running, and on top of that, there are several applications which are running. So like that, these are all different blockchains. There is a question right now which has come that how do these blockchains interact with each other, which is a very, very important problem for the industry, which is called interoperability. And that's something which Polkadot has done some, huge amount of effort in this direction. There is another, protocol called Cosmos IBC, inter-blockchain communication. They also have done a fantastic job in terms of, bridging the gap between these blockchains. So that's how is the overall concept you should understand. Deepak?
Perfectly explained, sir. Perfect. So why we have one more question from Parth. So where we can get info related to which node person validated a transaction and how he was awarded a gas fees.
First of all, you as a business user and application user, you don't need to worry about it. This is something which happens at the blockchain level. And like I was saying earlier, there are different ways in which these validators are selected to create the next block. And that also depends on the type of blockchain. So a person who is selected to create a block, okay, that person will create the block, validate the transactions as per the rules defined by that blockchain. Okay, and as long as that validator is doing its job properly, you don't need to care about who created that block, first of all. But there are places where you can go and find out this information. There is already these information pieces are available. You can go and make calls to the blockchain and get all this information. That is not a problem. Yeah, Deepak.
Sir, we have one generic question. So if you can summarize in 1 or 2 minutes, what is the difference between a Bitcoin versus a blockchain versus a Ethereum? So we have several questions regarding that. We have, I think we have discussed this yesterday so much. So if you can summarize in 1 or 2 minutes.
No, we discussed yesterday also. See, look, a blockchain is a technology which has removed the intermediaries from the picture. Understand that one very clearly. When did blockchain start? In fact, blockchain started with Bitcoin. Bitcoin was the first implementation of blockchain, but Bitcoin had several limitations in its utility. It, in fact, like I said earlier, Bitcoin is not Turing complete. What does Turing complete means? Turing completeness means if you provide significant or enough amount of resources, it could do any computation, right? Bitcoin cannot do that because Bitcoin does not allow looping. Allowing looping, there are different reasons for that. But then from Bitcoin, to remove the limitations of Bitcoin, Ethereum came. Ethereum created a framework. It gave a virtual machine kind of environment in which people could go and deploy their own business applications. Correct? So this is another blockchain. Blockchain and network in this context are synonymous. You can work another blockchain. Now, Ethereum also, did so much good to the system, but Ethereum also had some issues. Then other, blockchains started coming that how do we solve the problems of Ethereum? Then Solana came, Avalanche came, right? Then these are all layer ones, right? Phantom came. And like this, there are so many applications, blockchains, which share their security with Ethereum blockchain, and they are called as layer 2 applications, blockchains, such as Arbitrum. Now, Arbitrum has a different way to, create the blocks, do the validation, right? There is optimism. There are ZK technology based, so many ZK Stark based, ZK Snark based. All these different, blockchains are there, right? So all these are different blockchains which are trying to have, same purpose of, providing a platform for the business applications to run over them, right? On them, right? That's how exactly I would summarize it.
Yeah, thank you, sir. One question we have, then if something happens to their system, the system of the contributor, let's assume they got destroyed in the disaster, then data will be lost, question mark.
That's a very good question. See, the point is that is the beauty of blockchain, right? What it says that as long as there is one node which is running, I mean, you are safe. Now, the question is that, say, for example, for a particular blockchain, there are 10,000 validators, right? And typically, all these validators are spread across the geography, across the world. And if some of the blockchains, they, they get destroyed in some disaster, of course, the decentralization ratio or decentralization factor decreases. I agree with that. Our IBC media platform, where you have done sign up, when you go, after you log in, when you go inside, you will find the list of all the sessions where, you find the topic and the Zoom link, right? So when the sessions are being completed, we make an attempt to put the, the recorded videos there, right? So it may take sometimes a day or so because, we have to do some, we have to do some curation there. But, all these videos will eventually be, put there. Yeah,
this is an ocean, but just to keep things very, very simple. I think even if people are not from the background, I've seen chemical engineers, mechanical engineers doing very strong Solidity programming, Rust programming, doing a lot of stuff. All we have to do is focus on the basics, understand the logic, understand how the network is working, understand where you fall into, whether you fall into the backend, whether you fall into the interfacing layer, whether you fall into the presentation layer, whether you are only part of a dApp building team, or even from a business perspective. So the idea is to understand the basics, go back to the roots of what it means by understanding the core concept of how a transaction work or what the business process requires. And then I think keep things very, very simple. Do not be thinking about whether I'm eligible for it, whether I'm a mechanical or an electrical person, how will I do it? So the idea is no matter what the background is, keep things very, very simple in terms of understanding the basics. And that's the core focus here.